This is exercise 3.04, rearranging the subject of the formula. Now I've started a couple of these. In all of these questions we are trying to make x the subject of the formula. So if we look at the first one, we can see that x has been multiplied by a. The opposite of multiplying is dividing. So depending on whether you want to write divided by a on both sides, because what you do to one side of an equation you do to the other, you can see the a's will cancel on the right hand side and I'm left with x equals y over a. Now question number 2, once again x times y equals 7. I want to isolate the x. We need to do the opposite operation. The opposite of timesing is dividing. What you do to one side you do to the other. The y's will cancel and I'm left with x equals 7 over y. Number 3, I can see this says x divided by 10 equals y. The opposite of dividing is timesing. We want to times by 10. What you do to one side you do to the other. You can think of this as 10 over 1 if you like. The 10's cancel and I'm left with x equals 10y. Number 4, we want to isolate the x. It's had 1 added to it, x plus 1. I've thought of a number and added 1 to get the left hand side there. So the opposite of plus 1 is to minus 1 from both sides. So that x will equal 2y minus 1. Number 5 is quite easy as well. You see we're subtracting 3. The opposite of minus 3, the opposite operation is to add 3. So x must equal the same as y plus 3. Number 6, we're looking for x. It's been multiplied by 12. The opposite of timesing by 12 is to divide by 12. What you do to one side you do to the other. 12's cancel. And I can see that x equals c plus d over 12. Number 7, dividing by 3, both sides. 3's will cancel and x equals p over 3. Number 8, x plus 4. The opposite of adding 4 is to minus 4. What you do to one side you do to the other. Plus 4 minus 4 is 0, that cancels out. So x equals, it's hard to read that, 2y divided by 4. 2y minus 4. Number 9, I can see that x has been multiplied by 2 first and then has had 5 added. So to reverse that process, we're going to need to subtract the 5 first, which means y minus 5 equals 2x. Now to isolate the x, this is x multiplied by 2. The opposite of multiplying is dividing by 2. And x will equal y minus 5 divided by 2. If we think about number 10, we'll come up over here and have a go at number 10. We're going to need to minus the y on both sides. We'll get 5 minus y. And the last step will be dividing by 10. I'll let you work on that one. Now number 11 might look a bit tricky because of the minus 3. We've talked about some strategies for handling an equation like number 11. If we write number 11 here, and one strategy we've talked about is to change this and write it as minus 3x plus 8, which is the same thing. I've got a minus 3 term and I've got a plus 8 term. I just choose to write them the other way. And now it's more obvious to see that the first thing we need to do is to minus 8 from both sides. And now we're going to need to divide by negative 3. Now you might find the answer in the back of the book is slightly different to that. So we get x equals y minus 8 divided by negative 3. The back of the book might do it slightly differently. For example, you could add 3x up the top here, which now makes that a positive and then we'll write 3x equals 8. We'll need to subtract y, and the last step is to divide by 3. These two are actually the same, and either of them is correct. I'll let you have a go at number 12. I can see I need to subtract the 4y, divide everything by 3. Similarly with 13. Now 14 has caused a few questions, but if you just remember this as x times y plus 4 equals p, then the opposite of multiplying is dividing. That y plus 4 is just a number. If we knew what y was, we could work out the number. So because it's multiplied here, I can actually divide by the whole thing. What you do to one side, you do to the other. That's just a number, which will cancel with that number because it's multiplied. And when you have factors like that, we know that we can cancel top and bottom. So x will equal p over y plus 4. I'll let you have a go at number 15. Now number 16. A quarter kx equals y. We talked about this. We discussed one way of eliminating a fraction would be to multiply by its reciprocal. So if we just clear some space, go to the top here and rewrite it as 1 over 4 times k times x, 1 over 4 times k times x equals y, and I'm going to multiply by 4 over 1, and what you do to one side you do to the other. Now you can see multiplying, it doesn't matter what order we multiply them in, the 4's will cancel. A quarter times 4, 4 lots of a quarter. If you have 4 lots of a quarter, 4 quarters, you'll have 1 whole. So I'm left with k times x equals, and in this case it's 4y. You can think of that as putting it over 1. You can think of multiplying and getting 4y over 1. Whichever way you think about it, y times 4 is just 4y. And now we divide both sides by the k to eliminate it. And I get x equals 4y over k. So you have a look at that and check you agree with it. Maybe pause and try it again by yourself. And we'll have a look at number 17, because there are lots of ways to do number 17. One way to do number 17 would be to, because it's divided by x, the x when it's in the denominator is quite hard to change the subject of the formula. However, if you realise this is divided by x, we could do the opposite operation, which is to times by x. Some of us just write the times x on the other side. But if you want the working, what we're doing is the same operation to both sides. That will cancel. I'll get AB equals CX. Now I can see if I want x on its own, isolated, that's times C. So we could divide both sides and I'll get x equals AB over C. So that's one way to handle when the variable is in the denominator. You can do try the same technique with number 18. Number 19 we're just going to need to square root. We could have a look at number 20. 3x squared equals 2y. I can see I need to square root, but while the 3 is still there, it becomes a bit difficult, because if I square root this side and this side, you can see that I've still got the square root of 3 annoying me. So it would be easier if we, let's see if I can write over that again, 3x squared equals 2y. If we divide by the 3 first, x squared equals 2y over 3. And now I can see that x will be the same as the square root of this fraction here. I'm actually square rooting both sides now, like that. And I know that the square root of x squared is just x. I've squared a number, square root gets me back to the original number. And just to finish off, we can try number 21. We've got the square root of x divided by 3 equals y, and I think you can see that to undo that square root, to do the opposite operation, you would need to square both sides. What you do to one side, do to the other. Squaring a square root, inverses of each other, you square root and then square, you'll get back to the original number under the square root sign, equals y squared. This is x divided by 3, the opposite of dividing by 3, we've talked about this. Multiplying by 3, what you do to one side you do to the other. You might like to think of it as 3 over 1. X equals 3y squared. So have a look at that, check you agree with that, and perhaps pause and try some of these again on your own.